compositions of functions, it's really basically put combining functions together. So I'm just going to say combining functions. Now that we're well versed with function notation and the algebra of functions, we're just going to introduce some new notation. And this is an example of function notation, and this is read f of g of x. So what this is telling you is plug g into f. This can also be written f of g of x. I would recommend anytime you're given this notation to convert it to this notation, because this will tell you where to begin. You're going to begin with the innermost parentheses, and this is telling you to plug g into f. So if you're given f of g of x in this notation, just convert it this way. Now this is a composition symbol. That is not a multiplication symbol. That is not a dot. It is an open circle, which is the composition symbol. And again, this is telling you to plug the entire function g into f for x. So an example, let's say f of x is defined by 2x plus 3, and g of x is defined by x minus 8. Let's find f of g of x. Again, this is telling you to plug g into f. So we're going to rewrite this notation to say f of g of x. Now we can start with the innermost parentheses, which is g of x. And I know what g of x is equal to. It's right here. G of x is x minus 8. So instead of g of x, I'm going to write its equivalent. Not g of x, x minus 8. So take this and substitute it in for that. So f of x minus 8. Now I know what f of x is. It's 2x plus 3. And again, just like function notation, I'm going to open up a set of parentheses in the rule for f. So f is 2x plus 3. 2x plus 3. But I don't want f of x. I want f of x minus 8. So I'm just going to substitute an x minus 8 for x into the rule for f. And now we just have to distribute 2x minus 16 plus 3 and then combine like terms. 2x minus 13. So f of g of x equals 2x minus 13. Let's do another example. Let's say we have f of x equals x minus 2. G of x equals x squared minus 3. Let's find g of f of x. Since we're given a composition symbol, I'm going to rewrite this with a set of parentheses so I know where to begin. G of f of x. Now I know what f of x is equal to. It's x minus 2. So let's substitute that value. Not g of f of x, g of x minus 2. Why? Because f of x is x minus 2. So now this is telling me to plug x minus 2 into g for x. Well, here's g. G is x squared minus 3. So I'm just going to open a set of parentheses for x. X squared minus 3. And what am I substituting for x? X minus 2. Square by, get a try. This is telling you to multiply x minus 2 times itself. So this is x minus 2 times x minus 2. Don't forget that minus 3 at the end. After you FOIL this out, x squared minus 2x minus 2x plus 4 minus 3. and now we can combine like terms. Negative 2x is a negative 4x, and a positive 4 and a negative 3 is a positive 1. So g of f of x equals x squared minus 4x plus 1. Compositions of functions can have numerical values as well. So numerical evaluations of compositions. The numerical evaluation of a composition could be something like this. Let's say f of x equals radical 9 minus x, and g of x equals 2x plus 4. Let's find g of f of 5. Now this is telling you I'm going to be plugging in a number into f, plug in 5 into f, and then whatever I get in return, plug that number into g. So this is like a chain of events here. So let's rewrite this, g of f of 5. Well, I can figure out what f of 5 means. That's telling me x is 5, and I'm going to plug it into f for x. So first, f of 5 is what? Well, that's the square root of 9 minus x, 5, which is square root of 4, which is 2. So f of 5 is 2. So now take a look at this. Now I know what f of 5 is equal to. So really what I'm looking for is g of whatever f of 5 is equal to. I have already determined that f of 5 is 2. So now I no longer want g of f of 5. I want g of whatever f of 5 is equal to, 2. So now I'm just going to go back to my rule for g, and I'm going to plug in 2 for x. 2x plus 4, where x was 2. 2 times 2 is 4, and 4 plus 4 is 8. So just to summarize what we did here, if I have a compositions of functions, and inside my innermost parentheses is an x, my answer is going to be an x. It's going to be an expression or an equation. If my innermost parentheses is a number, then that's exactly what my answer is going to be. It's going to be a number. Whatever is closest to the number is the first function that you'll be evaluating. I would highly recommend to rewrite this composition notation using parentheses because it will remind you where to begin.